Subtract out the area of the pool, that will leave us the area of the concrete walk, which is 152 square feet. So here's how we get our equation. 2x plus 24, length times width for a rectangle, minus the 24 times 10, which is 240, equals 152. And now we just have to do the algebra and either factor it or put it in the quadratic formula. So I'm going to FOIL this out here, so I get 4x squared plus 20x plus 48x plus 240. Then we have our minus 240, and I'm also going to subtract the 152 over here because I know I have to set this equal to 0. So those do go away, and when we simplify, we get 4x squared plus 68x minus 152 is equal to 0. Now you can throw those numbers in the quadratic formula if you'd like, but they all are divisible by 4, so to make life a little easier, you could divide by 4 everywhere. And now you can throw those numbers in the quadratic formula. A is 1, B is 17, C is negative 38, or this one's pretty easy to factor, and I'm going to just save myself some time and do that. So of course we ignore the negative because it's a length that does not make any sense. And we find out that our concrete walk is 2 feet all the way around. 2 feet all the way around.
So stoked.
Hang in there. All right, this, we're not going to do this one, so you can skip that one.
Yes.
Cool. It's the Pythagorean theorem. It's not too hard, but I'm not having that one on the test. So. Perfect. Okay, this one we're just going to reason out based on what we know. So here's our general form of our parabolas. A times x minus h squared plus k. So first of all, they're telling us that a is less than 0. So that tells us what about the parabola?
Negative.
That, yeah, a is negative, so that means the parabola opens which direction?
Down.
Down. So goodbye B and D, right? All right, so it's either A or C. Now, some of you can just reason this out. They're telling us that the vertex, H is greater than 0, but K is less than 0. So just so I don't have to think so hard, I'm going to go ahead and let H be like 2, that's greater than 0, right? And then I'm going to let K be negative 3 because that's less than 0. So I'm just giving an example. So where approximately would 2, negative 3 fall on the parabola? Does A make more sense or C? A, right? Because if you go 2 over and 3 down, you would be down here. So you have to be down here somehow anyway because of this, the way that H and K are labeled. So our answer is A here. All right, does that make sense to everybody? All right, good. All right, well then let's graph a parabola here. All right, this is the form I like it in because I can tell the vertex immediately. What is our vertex here? 0, negative 2. So remember, you can think of that as 1/2 x minus 0 squared minus 2. It's whatever makes this 0 and then this number out here. So again, that's good news for us. And then what's our axis of symmetry?
0.
X equals 0. It's always the equation x equals 0. I would be ecstatic if you give it to me in equation form. And what's the domain?
All real.
Good. I would be ecstatic if you don't miss that as well. Remember, all the domains of the parabolas are all real numbers. Now the range is a little trickier. Does this parabola open up or down?
Up.
Up. How do you know?
Positive.
Positive 1/2. And is it narrower or wider or normal?
Wider.
Wider. Okay. So we know that this opens up. So when the parabola opens upward, you start with the range, or you start with the y value, which is of the vertex, which in this case is negative 2, and you go to positive infinity. If it opens downward, you start with negative infinity and you go to the y value of the vertex. So there you have it, and then we're going to graph this, so I need some ordered pairs. The best part is to put your vertex in the middle and do 2 numbers below and 2 numbers above. Then you can put either 2 in the equation, and then the other 2 we know are the same because of symmetry. And so I'm going to do the positive ones. So if I put 1 in here, 1 squared is 1. Half of 1 is a half. 1/2 minus 2 is -1.5, or -3/2, but I'm going to use the decimal because it's easier for me to write in my chart. And then I'm going to put 2 in there. 2 squared is 4. Half of 4 is 2. 2 minus 2 is 0. And now I can graph it. And 2 0. All right, it's opening upward as I expected. I'd be very upset if it wasn't. And it's wider, so everything is making sense based on what we know from that equation. If it's not in that form, then we're going to find the vertex using the vertex formula, which is the one we're going to do next. Any questions on this problem?
Got nothing.
All right, here's one more. So this one is not in that nice, neat form. I cannot tell what the vertex is just by looking at it right now. So I'm going to use the vertex formula, which is -b over 2a. So a is -1 and b is 4. So we get -4 over, oh, I'm sorry, a is -1, excuse me.
B is
4, yeah. But so -b over 2a. So we get a +2. So that's our y value. I mean, our x value. Sorry. Crazy. That's the x value of the vertex. Okay, that's our x value.
Hang in there.
Now we're putting that in to find our y value.
We just plug it into the.
We just plug it into the equation. So be careful with your sign here. This is saying square it first and then take the opposite. -4 plus 8 is 4, and 4 minus 1 is 3. That's my y value of my vertex. And what's my axis of symmetry?
2.
X equals 2. What's my domain? All real numbers. Now, does this parabola open up or down?
Down.
Down. How do you know?
Negative.
Negative. And narrow, wide, normal. That's what I call normal.
Okay.
So there's a 1 there, right? There's no 1/2 or there's no 2. So it's just going to have our normal shape. And so our range, because this opens downward, is going to start at -infinity and go to 3. Good. And finally, we want to graph this lovely parabola. Again, we have our vertex, which I'm going to put in the middle here. And I'm going to use 0 and 1 here. So I put 0 in. I can see that that's going to be -1 because everything else zeroes out. And then I'll just work 1 out for you here. I'm going to put 1 in there. And we get 2. And now I'm ready to graph. And it's opening downward. Very happy about that. And it's a normal shape. It's not wider or narrow. It's just like our shape of our x squared problem. Pardon? Because it's there's like a 1 in front of here, right? And so if there's a 1 there, it's just our normal shape, like our x squared. If it were between 0 and 1, like 1/2, 1/3, it would be wider.
Oh.
And if it was greater than 1, it would be narrower. So 2, 3, 4. That's why. Okay. This one is the horizontal one. We will not have a horizontal one. I don't know what's going on with that slide. That's weird. Okay. I'm just gonna write it on a whiteboard slide, so I don't know what's going on with that, but, it is this equation, right? It is this problem right here. These are from the very last section of our, chapter. And you will either have one like this or one like 25 on your test, not both, one or the other, depends on which test you get. All right, so here, these are the inequalities. We set it equal to 0 first. And then you either factor it or you can throw it in a quadratic formula. It's your choice. So then we set our factors equal to 0. And we get our two solutions. Again, these are the same solutions that will come out if you put it in the quadratic formula. And then we have to divide our number line up accordingly. And then we have to test each point, or 1 point from each interval. All right, I'm going to test -6 here. 72 minus 42 is 30 greater than 15.
Mm-hmm.
True. So we're true here. Of course, here's my friend 0, so I'm going to test 0 here. So I get 0 greater than 15. True or false? False. And finally, I need a number over here. I'm going to choose 2. Is 22 greater than 15? It is. So that means, and I have a greater than, so I'm going to use parentheses here. So parentheses and shade everything to the left here, and a parenthesis and everything to the right. And of course our interval notation is from -infinity to -5, union 3/2 to +infinity. So when they're quadratic like that, again, you're going to get your two solutions. You're going to divide your number line up. You're going to test each interval and shade where it's true. Be careful if it's a greater than or equal to or less than or equal to, you're going to use the brackets. All right, I have one more to show you. Is everyone okay with that one? All right, or you're going to have one like this. Again, this came from our last section. So to divide this number line up, we have to just treat it like an equation. So we're going to say 5 over t minus 4 equals 1. I'm going to cross multiply here, and t is equal to 9. So that's 1 point on my graph. The other point comes from whatever makes the denominator 0. So what would make that 0 there? 4. And now I'm going to test points in those intervals in the original inequality. So I'm going to test 0 first. So we get -5/4. Is -5/4 less than or equal to 1? It is. And between 4 and 9, I'm going to test 5. Is 5 less than or equal to 1? Negatory. 5 is not less than 1. I know. And then I'm going to test 10. Again, test a point from the interval. And 5/6 is less than or equal to 1. True. All right, now here you have to be careful. We are supposed to use a bracket, but remember we can never use a bracket on the number that causes the denominator to be 0. So this one has to get a parenthesis, but the 9 gets the bracket. So here we have -infinity to 4 with a parenthesis, union the bracket 9 to +infinity. All right, and that is the review, and we will see you on Monday.